Okay, so hello and welcome back. Now we want to do a quick exercise and I'm going to ask you to identify whether these things are true or false. Okay, true. Oh, no, that looks bad. It's true or false, right? True or false in the exponent law. So I'm going to give you a question in each one. I'm going to give you the right hand side and also the left hand side. And I want you to do 2 or 3 things for me. One, I want you to tell me whether it's true or false. Two, I want you to give me the exponent law that we have to use. Okay, and then 3, I want you to test whether it's true or false. And I think maybe you should do this last. I want you to tell me whether it's true or false last, after having checked the exponent law and also giving me using a numerical example to prove your answer. Okay. So let's say I've got a, and let's choose a different color. Let's be colorful. I've got a to the power, ooh, mama, 8, ooh, no, a to the power of 2 raised to the power of 3. Well, what is the law that we're going to follow here? The law that we have to use, go back to your notes. If you've made notes on this, go and find the law. It's a to the power of m. If I raise that to the n, then it's going to be a to the power of m times n. So the question I have for you over here is true or false? A to the power of 2 raised to the power of 3 is a to the power of 6. That's my question. Is it true or is it false? Well, let's see. Does that look like the law that you have to apply? That's 2, that's 3. Is 2 times 3 equal to 6? And the answer is yes. So according to the law, it's true. But let's test it. I'm going to call this over here the left-hand side. And I'm going to call this over here the right-hand side. If I look at the left-hand side, I'm going to say, well, the left-hand side, if I just choose any random a, let's make a value of, give me a value for a. Let's a be equal to 2, right? What is 2? If I let a equal to the 2, then I raise that to 2, and I raise that to 3. The left-hand side is going to be 4 to the, oh no, that looks bad. Looks very bad. Oh no. Okay. It's going to be 4 raised to the power of 3. And 4 times 4 is 16, and 16 times 4 is 64. Let's see if I can do it for the right-hand side. Well, again, I'm going to let a equal 2. So I'm going to make it 2 to the power of 6. And then I'm going to say, well, okay, 2 to the power of 6 is 2 times 2 times 2 times 2 times 2. That's 5 multiplied by 2. And then you'll notice 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 multiplied by 2 will give me 64. Now, did I get the same value for the right-hand side? 64. And did I get the same value for the left-hand side? So I can say the left-hand side is equal to the right-hand side, and therefore the above is true. Okay, so that's the first true and false question. Let's go to the next one. True and false, or true or false. Okay, so the next true or false question is going to be x to the power of 3, y to the power of 2 is equal to, let's make it x to the power of 5, y to the power of 2. Now, let me tell you something about mathematical equivalence. That is an equivalence sign, right? Essentially, this is an equivalence relation. What we're really talking about here, we're saying that the left-hand side is really equal to the right-hand side. Now, is it true or is it false? Well, yeah, I don't think you can particularly relate it to a law that we've learned, but you're going to have to look at some common sense. Clearly, this thing here is identical to that thing there. But what about this thing? Is this thing exactly the same as this thing over here? Right? Is it exactly the same? Is it exactly the same? No, of course it's not the same. Now, if it's not the same, then this is not true. It cannot possibly be true because it's not true for all x and y. Now let's see why is that so. Well, I'm going to tell you something about proving things, right? in the next, I think, in the next video. Okay, let me come back to this. Let's quickly talk about proving things.